Hi, 10th graders. So I'm out on a field trip with some of your classmates, and while I'm gone, you are going to be working through this video together. Make sure someone is up at the computer hitting play and pause as you go along so that everyone has time to do the work, and follow these directions. You should be good to go. So hit pause, come back in 5 minutes, and we'll go over the answers for the do now. All right, so your objective for today is to be able to calculate the percent composition of an element in a compound. And we'll go over the do now answers in just a second. Here's your agenda. After we go over the do now answers, we'll do a couple examples of percent composition that you'll write down in your notebook. You'll have a couple problems to do together with a partner for practice, and then with the remaining time, you'll be able to work on some homework. Your homework is to finish the week 14 homework, page 2, and that is due the next time I see you. So here are the answers to the do now. So this first one asks you to calculate the molar mass of carbon tetrachloride. The first step is to write down the correct formula for carbon tetrachloride. We'll make a list of each element in carbon tetrachloride and how many atoms of each element. Multiply that times the molar mass for each element. We're going to multiply across. And then we'll just add down. And you have two choices for your units here. You could either write AMU or grams per mole. Letter B, sodium carbonate. The formula for this one is a little bit trickier. Here are the two ions that go into this ionic compound. Cross the charges, and you get Na2CO3. Make a list. Remember that carbon and oxygen are two separate elements. We're going to list them separately. Write down how many of each times their molar mass. We'll multiply across. And add down. And there are your do now answers. So today we're going to focus on percent composition, which takes molar mass and uses it to figure out the percent by mass of each element in a compound. So for example, if you had sodium chloride, what percent of that by mass is sodium and what percent is made up of the chlorine? Here's your equation. Percent composition is the mass of that single element that you're interested in divided by the molar mass of the whole compound times 100. So here are two examples for us to work through together. The first one says, calculate the percent composition of each element in sodium chloride. So the first thing we're going to do is make sure that we have the correct formula for sodium chloride. And if you just looked at what percent by atoms you had, you would find that 50% of the atoms are sodium and 50% of the atoms are chlorine. However, that's not by mass, that's by counting atoms. To figure it out by mass, we first have to figure out the molar mass. So the same way we did this last class, make a list, write down how many of each of these you have, times the molar mass, multiply across, and add down. So this is exactly the same process we did before. This is the molar mass. However, we're going to add a step to figure out the percent composition. We're going to take this number and divide them by the whole molar mass to get percent composition. So 22.99 divided by 58.44 times 100 because we want a percent. So we'll take 22.99 divided by 58.44 times 100. and I got 39.34%. And here, it's generally appropriate to use 4 significant figures, or 2 decimal places anyway, when we figure out percent composition. Same thing for chlorine. So this percent up here is for sodium. For chlorine, we have 35.45 divided by 58.44 times 100. And I got 60.66% for the composition of chlorine by mass. And we can check these by adding these two up, and you should always get 100% total. Let's look at one more example. So example 2 is the same thing for aluminum hydroxide. What is the percent composition of each element in aluminum hydroxide? First, we're going to write down the correct formula. Remember that aluminum has a charge of 3+, hydroxide is -1. Make a list. Write down how many atoms of each one. Multiply by the molar mass. Multiply across. And add down. I got 78.01. The next step, which is the new step that we're just learning right now, is to take each of these numbers, which is the total mass of just that element, and divide it by our total molar mass down here to get the percent composition by mass for each element. So 26.98 divided by 78.01 times 100 to make it into a percent. I got 34.59% for aluminum. All right, so 48 divided by 78.01, and then finally, and times 100. Oh, so let's calculate this. 48 divided by 78.01, 61.53%, and that is the percent by mass of oxygen. And then 3.03 divided by 78.01 times 100. And that gives us 3.86% for the hydrogen. Great, so here are 3 practice problems for you to do. So hit pause, let's take 10 minutes to work through these with a partner, and we'll come back and check our answers. All right, here are the answers to the practice problems. For H2O, you should have gotten a molar mass of 18.02. For hydrogen, 11.21%, and for oxygen, 88.79%. For letter B, calcium chloride, CaCl2, a molar mass of 110.98. For calcium, 36.11%, and for chlorine, 63.89%. And finally, for aluminum nitrate, here's the formula. The molar mass is 213.01. The percent composition for the aluminum is 12.67. For the nitrogen is 19.73. And since a lot of this molecule is made up of oxygen, and oxygen's pretty heavy, 67.60% for oxygen. So here's an extension problem. How many grams of aluminum are present in 10 grams of aluminum phosphate? So this is asking you not for the percent of aluminum, but how many grams out of that 10 grams of the compound is made up of aluminum. So let's work through this together, and then you'll be all set to start working on your homework. So we have aluminum phosphate, which is AlPO4, the 3's cancel out, and we're first going to calculate the molar mass. So we have aluminum, phosphorus, and oxygen, 1, 1, and 4. Aluminum is 26.98. Phosphorus is 30.97, and oxygen is 16. We're going to multiply across. (16 times 4, 64). Add them up. And we get 121.95 grams per mole, or AMU. And now we're only interested in the aluminum. So I'm going to calculate the percent composition of just the aluminum. 26.98 divided by 121.95 times 100. And I get 22.12% aluminum. And the question is actually asking, out of that 10 grams of aluminum phosphate, how many grams of it is just made up of aluminum? So we're going to take the number of grams, and this is really easy. We're just going to multiply by 22.12%. Now remember, that's just like doing this, 0.2212. You have to convert it back into a decimal to do it in your calculator. So 10 times 0.2212 is 2.21 grams of that aluminum phosphate are just made up of aluminum. So your job now is to work on page 2 of your week 14 homework, and that's due the next time I see you.